Thank you, dancers, for such a wonderful performance. A very warm welcome and morning to all of you, and welcome to Ho Chi Minh City University of Technology and Engineering. Ladies and gentlemen, we have just appreciated a dance performance inspired by a song called Bèo Giạt Mây Trôi, roughly translated as floating duckweed and wandering clouds. This is one of the most beloved traditional folk songs and melodies in Vietnam, and that dance had just given us a glimpse into the Vietnamese culture, beauty, and also the vibrant spirit of Vietnam. What a wonderful way to start our program today, isn't it? So with such wonderful beginning, today we would like to welcome all of you to the 8th International Conference on Green Technology and Sustainable Development, or GTSD2026. And my name is Sương, a lecturer from Ho Chi Minh City University of Technology and Engineering. I am very honored to serve as your Master of Ceremonies for this opening ceremony of the conference today. So on behalf of the organizing committee, we would like to extend our great gratitude to each and every one of you for taking the time to join us in this meaningful conference. Your presence, your expertise, your contribution will be what makes our conference a valuable platform for exchanging ideas, fostering collaboration, and advancing sustainable development. So once again, welcome to GTSD 2026. Ladies and gentlemen, before we proceed any further, let me give you some important instructions. For your safety, in case of an emergency, please exit the conference hall immediately. So you will find 4 exit doors, one in each corner of the conference hall. And once you are outside, please proceed to the assembly points located nearby on my right-hand side. Also, please remain calm, because your safety is our top priority, so just follow the instructions given. One more thing, our medical staff is on standby near the back of the conference hall, so if you need any medical care, then you can just proceed to them. They are very ready to help you. Additionally, after the morning plenary section today, we would like to invite all the participants to join us for a luncheon at 12 o'clock right here in this conference room, and it will be a great opportunity for you to network with each other. And finally, for your information, the bathrooms are located just behind you at the back of this conference hall in case you want to answer the nature's call. Thank you so much for your attention. Ladies and gentlemen, as the world continues to navigate the challenges of climate change, the pursuit of green technology and sustainable development has never been more important. Today's global challenges call not only for innovative solutions, but also for strong partnerships and the open exchange of knowledge across disciplines and across borders. It's in this spirit that we gather today in the 8th edition of the International Conference on Green Technology and Sustainable Development, or GTSD 2026. Now, in its 8th edition, GTSD has become a well-established international forum where researchers, scientists, academics, industrial professionals, and policymakers come together to share ideas, present their cutting-edge research, and explore innovative solutions for a more sustainable future. GTSD 2026 is proudly co-organized by Ho Chi Minh City University of Technology and Engineering, formerly known as Ho Chi Minh City University of Technology and Education, Vietnam, and Tôn Đức Thắng University in Vietnam, together with National Taipei University of Technology in Taiwan, Adelaide University in Australia, and Quezon City University in the Philippines. Why not give a big round of applause for such a wonderful collaboration? Ladies and gentlemen, it is now our honor to introduce to you our distinguished guest today. From Vietnam Ministry of Education and Training, please join me in welcoming the Vice Director of Science, Technology and Information Department of the Ministry of Education and Training, Dr. Trần Nam Tú. It's also our great honor to introduce to you our keynote speakers of this meaningful conference. Let's give it up to welcome the Director and Educational Counselor of the Education Division, Taipei Economic and Cultural Office in Ho Chi Minh City. He's also the distinguished professor from Department of Mechanical and Electromechanical Engineering, National Sun Yat-sen University from Taiwan. Yeah, you have seen the wave from Professor Wei Chin Lin. We are also delighted to introduce to you a character from the School of Civil Engineering and Construction, College of Engineering and Information Technology from Adelaide University, Australia. Please welcome Professor Chen Chu. And the final keynote speaker for the conference today, please welcome Mr. Brian Belwon-Cole, the CEO of Integra DMC and Innovative Design. We also have the privilege to welcome to our conference today some special guests from the universities that collaborate with us in organizing this conference. Please put your hands together to welcome Professor Wen Chun Wong, the General Co-Chair of the conference from National Central University, Taiwan. Please join me in welcoming Dr. Bùi Thanh Khiết, the Vice President of Thủ Dầu Một University. We are also honored to welcome Dr. Nguyễn Thạc Quang, the Vice President of the University of Transport and Communications, Ho Chi Minh City campus. We also have the honor to welcome Associate Professor Trần Thanh Phương, the Dean of Electrical and Electronics Faculty of Tôn Đức Thắng University. From Ho Chi Minh City University of Technology and Engineering, the host of GTSD2026, we are very delighted to introduce to you Associate Professor Dr. Châu Đình Thành, the Vice President. Another important character we would like to introduce to you. Let's give it up for Associate Professor Dr. Vũ Văn Phong, the Acting Director of Science and Technology Office. And last but not least, I would like to extend a warm welcome to the representatives from the Science and Technology Department of Ho Chi Minh City, the Ho Chi Minh City University of Technology, Vietnam National University Ho Chi Minh City, Nông Lâm University Ho Chi Minh City, and Tiền Giang University, especially all the authors, researchers, lecturers, students attending this event today. Thank you so much for joining us. Ladies and gentlemen, now let's take a moment to acknowledge and express our appreciation to the generous sponsors who have contributed to this event, either in finance or special support. Let's show your appreciation to the System, Man and Cybernetic Society, SMC. Let's give it up for the international publisher Springer. Our appreciation also goes to the Institute for Electrical and Electronics Engineers, IEEE. Last but not least, our special thanks also go to Integral DNC from Korea and Innovative Design from the US. Our special thanks also go to the faculty members of universities and other international scholars who have significantly contributed to the paper review, publication, and other organizational work for this conference. Thank you so much for all of your contributions. We are very honored to have you as part of our journey. Ladies and gentlemen, it is now my great honor to present to the stage the Vice President of Ho Chi Minh City University of Technology and Engineering for his welcome remarks. Let's put your hands together to welcome Associate Professor Dr. Châu Đình Thành.
Dear Dr. Trần Nam Tú, Deputy Director, Department of Science, Technology and Information, Ministry of Education and Training, distinguished guests, honorable keynote speaker, esteemed researcher, ladies and gentlemen. It is my great pleasure and privilege to welcome you to the 8th International Conference on Green Technology and Sustainable Development 2026, GTSD2026, hosted by Ho Chi Minh City University of Technology and Engineering. On behalf of the university, I extend my warmest greeting and sincere appreciation to all distinguished delegates who have joined us from around the world. Your presence reflects our shared commitment to advancing scientific knowledge and technological innovation for the greener, smarter, and more sustainable future. GTSD has grown into a well-organized international forum that connects researchers, educators, and industry leaders to exchange ideas, present cutting-edge research, and foster collaboration in the rapidly evolving field of green technology and sustainable development. This year's conference is proudly co-organized by Ho Chi Minh City University of Technology and Engineering, together with Tôn Đức Thắng University, Vietnam, National Taipei University of Technology, Taiwan, Adelaide University, Australia, and Quezon City University, the Philippines, demonstrating our strong commitment to international academic collaboration and excellence. The overwhelming response to GTSD 2026 reflects the increasing global interest in these important research areas. This year, the conference received 655 paper submissions from the researchers around the world, following the rigorous peer review process conducted by our International Technical Program Committee and reviewers. 286 outstanding papers has been accepted for presentation. This contribution represents the latest advance around the broad spectrum of topics ranging from the artificial intelligence, intelligent system, renewable energy, smart grid, robotics, Industry 4.0, and sustainable engineering to circular economy, green materials, environmental sustainability, and sustainable infrastructure. At a leading institute in engineering, technology, innovation, and applied research, HCM UTE remains firmly committed to promoting academic excellence, fostering international partnership, and contributing to innovation. We believe that the substantive discussion and collaboration established during the GTSD 2026 will inspire new research directions, strengthen international partnership, and accelerate the development of sustainable technology that benefits both our region and the world. I would like to express my deepest appreciation to our keynote speakers, authors, reviewers, session chair, sponsor, technical sponsor, organizing committee member, volunteer, sponsor, integral company, and partner institution for their dedicated and invaluable contribution in making GTSD 2026 possible. Finally, I wish all participants a successful conference and an enjoyable stay in Ho Chi Minh City. May your time at GTSD 2026 be professionally rewarding, intellectual stimulating, and professional memorable. Thank you very much.
Thank you so much, Associate Professor Dr. Châu Đình Thành, for the warm welcome. Ladies and gentlemen, we are very delighted to have the presence of our guest of honors from Vietnam Ministry of Education and Training in this international conference today. It's our pleasure to present the Deputy Director of Departments of Science, Technology and Environment from the Ministry, Dr. Trần Nam Tú, for his special remarks. Please welcome Dr. Trần Nam Tú.
Dear Associate Professor Dr. Châu Đình Thành, Vice President of Ho Chi Minh University of Technology and Engineering, distinguished guests, honorable keynote speaker, researcher, ladies and gentlemen, good morning. It is my great honor and pleasure to join with you today at the opening ceremony of the 8th International Conference on the Green Technology and Sustainable Development 2026. On behalf of the Ministry of Education and Training, Vietnam, I would like to extend my warmest greeting and sincere congratulations to Ho Chi Minh City University of Technology and Engineering, the co-organizing university, distinct keynote speaker, researcher, industry partners, and all participants from around the world to join the conference very important today. The Ministry highly appreciates the continuous efforts of the organizing institutions and the maintaining GTSD at the prestigious International Scientific Forum. Over the years, this conference has become an important platform where the university, research institutes, enterprise, and policymakers come together to exchange academic knowledge, introduce the new scientific achievement, effort in interdisciplinary collaboration, and develop practice solutions for the sustainable development. Today, science, technology, innovation, and digital transformation has become the principal drivers of the national competitive and sustainable growth. In Vietnam, the party and the government have identified this area as a strategic platform for the national development in the new era. In particularly, Resolution number 57 has established a new vision for the development of the science, technology, innovation, and digital transformation. The resolution placed university at the center of the national innovation system, not only as the institutes for the education and research, but also as the creator of the new knowledge, incubator of the advanced technology, and strategy partner of the enterprise to promoting social economy development. For the higher education system, it means the transformation in the both sides, mindset and action. Universities are expected to move beyond measure successful mostly by the number of the research projects. Instead, Greece must be placed the quality and international impact scientists, publication, development, the IP, intelligent property. And the government of Vietnam is therefore promoting many policy, to encourage university to enhance research excellence, establish internationally recognized research groups, expand collaboration with the enterprise, and celebrate the commercialization of the research outputs and outcome. University should formulate a business research strategy, invest the high quality human resources, develop strong interdisciplinary research team, promoting open innovation. They should regard to the international publication, patent, technical transfer, and innovative product not merely in the promotion indicators, but also creating contribution to national development and global scientific advancement. Every researcher has an important mission. Beyond publishing scientific paper, researchers expect the pursue the high impact researcher collaborates across discipline and borders. The Ministry of Education today, we also call upon university, research institute, enterprise, and international partners to work together to implement the vision of Revolution 57. Let us join both building a higher education system where the scientific publication and the accompanied by the impactful innovation, where research results become the technology and the products service society. Ladies and gentlemen, the term of the GTSD2026 is therefore high related and timely. Green technology and sustainable are no longer optional choice. They are the essential pathway towards the resilience and the prosperous future. Achieving this vision requires stronger partnership among university, research institute, enterprise, and government across countries. I'm delighted to learn that the year conference attracts a large number of very high quality papers from the researchers from around many countries. This impressive participation not only grow the deputy GTSD, but also the increasing global commitment to advancing green technology and sustainable innovation. I firmly believe that the scientific discourse, keynote presentation, and collaboration exchange during this conference will imprise new ideas, establish meaningful international partnership, and lead to innovative research outcomes that create lasting value of our societies. I wish the 8th International Conference on Green Technology and Sustainable very success.
Ngô Đình Thành to present a certificate of appreciation as a token of gratitude to our keynote speakers. And we would like to also invite to the stage Professor Wei Chi Lin from National Sun Yat-sen University, Taiwan, Professor Chian Chu from Adelaide University, Australia, and Mr. Brian Bewon Cole from Integral DNC and Innovative Design to receive the certificate of appreciation from the organizers of the conference. Let's give them a big round of applause. And can you all stay on the stage for a moment, please? So we will now have a group photo, so please remain on stage. Ladies and gentlemen, to capture the first moments of GTSD 2026, we would like to invite all the keynote speakers, the sponsors, the distinguished guests to come together on stage for a grand big photo. Let's welcome to the stage Dr. Trần Nam Tú, Associate Professor Dr. Châu Đình Thành with them already, and the three keynote speakers, together with Professor Wen Chun Wang, Dr. Bùi Thanh Khiết, Dr. Nguyễn Thạc Quang, Associate Professor Trần Thanh Phương, Associate Professor Dr. Vũ Văn Phong, Associate Professor Dr. Nguyễn Văn Chúng, and all the deans and directors of the faculties and centers of Ho Chi Minh City University of Technology and Engineering who are present with us today. Please come to the stage and have a big photo. For a better photo, can you all take one step forward, please? Can you all take one step forward? Maybe 2 or 3 steps forward to have a better photo, please. You have more space, right? Another photo, but just step forward a little bit. Okay, so let's take a picture together to create a lasting memory of this wonderful gathering at the GTSD 2026. Thank you so much, everyone. Thank you all for being a part of our journey. Ladies and gentlemen, that also concludes our opening ceremony of the 8th International Conference on Green Technology and Sustainable Development, GTSD 2026. Without any further ado, we will now move on to the plenary section with 3 special keynote presentations. But let me remind all the speakers that each presentation should last for about 40 minutes, including a very short Q&A section at the end. And for the audience, if you have any question, please raise your hand. Our staff will give you a microphone so that everyone can listen to the questions clearly. And we kindly request that you keep the questions concise and focused to allow for as many questions as possible. And due to time constraints, for further discussion, we suggest that you can engage with the speakers during break time today or during the networking lunch. Ladies and gentlemen, now I'll give the floor to the co-general chairs of GTSD 2026, who will now moderate the plenary section. Please welcome Associate Professor Dr. Châu Đình Thành, our Vice President, and Associate Professor Dr. Vũ Văn Phong, the Acting Director of Science and Technology Office from STM UTE. The floor is yours.
morning. First of all, I would like to invite Professor Wei Chen Lin, who he will present the speech titled Smart Agriculture Robots Transforming the Current and Future of Farming. Okay, please.
So good morning. So first of all, I would like to say thank you for the invitation. So it's my honor to join this wonderful conference. So as you can see, I'm from the National Sun Yat-sen University. So today, first I would like to share some smart agricultural results from my lab. And then also, I would like to share the result, the result from my student. Okay, so firstly, I would like to give a briefly background about my research. Sorry. And then I will share the 3 cases. So I would like to share the 3 cases about the smart agricultural technology which applied indoor, indoor and also the outdoor. And then if I have time, I would like to share our research about the ego-assisted exoskeleton and also some smart labor technology. And before I start, I would like to say thank you for all contribution. All results was done by my student. And then before I started, I would like to, I have one question for everyone. So why we need a smart agricultural technology now? So as you know, current agriculture facing several challenges. So as you can see, like pests, disease, and also like soil degradation, right? And then, but I think the major challenge is global warming. And from Taiwan side, we also face another severe challenges, which is labor shortage. So, and my second question is why we need smart agricultural technology. So after we have a smart agricultural technology, what kind of benefits can smart agricultural technology can bring to us? So as I mentioned, the labor shortage is a major challenge, right? And then also, if we have a smart agricultural technology, we can do like we can have a high. Touch. Sorry, we can have do the high efficiency and productivity controlled by the smart agricultural technology. So as I mentioned, the first challenge is its labor shortage in Taiwan. I didn't touch, so it just automatically changed. Why? Okay. So as you can see from this figure, so the Taiwan is already in the super aged society by 2025. So almost one third of the population, it's over, the age is over 65 years old. Over 45, it contains almost 88, reach to the 90%. So This is a situation in Taiwan. So now everyone talking about semicon and TSMC in Taiwan. So I would like to share one information for everyone. So to mention how serious challenges about the labor shortage in Taiwan. So here maybe 52,297 students. So the total amount is higher than the Taiwanese graduate student. So now Taiwan, we are facing this labor shortage challenge. Then how about last night I checked the website. So how about the situation in Vietnam? So I think from this population structure, so you can see the structure, the population structure of Vietnam is still very, very healthy. The average year in Vietnam is around 34 years old. And then so that means there is no labor shortage challenge in Vietnam now. Then another second challenge, as I mentioned, is global warming. So during the past 100 years, our global general temperature was rising around 1.3 degree. Okay, so as you know, last year we have a highest temperature which is around 40 degree in Hanoi. And then this challenge, climate change, it's affected not only the plant growth, but also I think the serious issue is around it's our lives, okay? And also the important thing is climate change is irreversible. So we only can slow down, so we cannot modify, we cannot improve. Okay, so this is Taiwan, we also facing the same challenges. So during the past 1 year, so also the temperature raised to around 2 degrees C. So for this challenge in agriculture, so my personal opinion is we need one suitable environment for plants and agricultural cultivation. So and this one we can call control environmental plant production system. And so generally it's a greenhouse system. And here I would like to share a few the research result from my student. So first is from my opinion, so before we have a smart house technology, right? So that we can use for service for the human. So like now we can use our cell phone and to monitor the situation of your house. And then before you go home, you can use cell phone to control the air condition and then the TV and everything and watch the situation of monitoring your house. Right? So I think the same situation. So before the smart house technology is a service for human, but we can apply the same system to instead of human to the plants and agriculture. So we can do the cultivation via our like a cell phone and also the iPads. So this one, we just need to, I think this is a very common technology now also already used in Taiwan, commonly used. So we just need to set up a central control system as like a PC inside of your greenhouses and then connect with all sensor and actuator to this PC, right? And then so sensor can monitor the condition and situation inside of the greenhouses, and then when we need any like treatment and action, so we can activate the actuators such as like we can switch on the air conditioner to make the temperature cool down, and then we can open the spraying the nozzle to spray the chemical and reduce the housing temperature. So then we can apply this not only like for the vegetable, but also the fruit and also the orchid. So this is one of case before we cooperate with one Taiwanese company, and then they already established the 3 greenhouses for orchid cultivation in Dong Nai. So now it's Ho Chi Minh City. So then I would like to show you the result from the orchid project. So we just finished last month. So as you know, the orchid plays a big market value in Taiwan. So every annual value is around $2 million USD per year. So then about 90% of the product export to the US. Okay, so the local domestic market costs not so much, just few 0.2 million USD. So then what does the farmer have to do in their daily work? Every day they have to rotate to manage the orchid. For example, they have to make the same direction of the orchid leaf, and then they have to pick up and withdraw the diseased orchid. So and we call in Taiwan yellow leaf disease. Okay. So then so now in this industry is still very labor intensive industry. So everything like you can see the farmer arrange the orchid by hand, and then they have to adjust the posture of the orchid leaf to improve, to keep the space for growth, and then to make sure they can get good quality of growth, high quality of orchid. So then the mission of this project is make the vision guide robotic, and then has control the robot grape, and then to manage and carrying the orchid growth. So then here, as you can see, this is before the farmer just randomly put the orchid parts inside of orchid basket, and then we design a robot, the contemporary robot, to manage the order and the position. So here I would like to show you sorry. Yeah, so as you can see this, the robot grab and hold it and manage and keep the same space. Sorry, I don't have a laptop, otherwise I cannot jump. So as you can see this, and then make the same order, the same space to each orchid basket. So the major, I think the unique target of this program is we have to make low cost of a robot. So that's why we don't use the robot arms. So, okay. So then, as you can see here, so we use student use a camera to stimulate the direction of the orchid. Okay, and then use the pin, the grip. It looks like a chopstick to arrange, to rotate the orchid, the order of the orchid. So you can see here. So then it's a changeable grip. So we use because the space. This is a tiny, the 2.5 inch of orchid. So there is no big space to handle. And also the parts, it's a plastic, it's very soft. So then we use the two kind of like a chopstick type to push and then to rotate. And then here has two camera to detect the whole, the order of the leaf, and then make everything in the same direction. So then after finish this part, so the car can automatically move to the next station and to repeat the same operations. So this is one function. Another function is isolation. So then now we are using the near infrared camera to detect the health of the leaf. So if the orchid infected by the yellow leaf disease, so then we use a robot to pick up, to withdraw and to isolate, and for preventing the infection between each orchid. So you can see this. So then the first find some disorder, so then make a good order, and then another if find the orchid infected by the yellow leaf disease and pick up and remove. Yeah, so like this one. So then through into the tank. And then after that, because we would like to avoid the contamination, so then this chopstick grip will go back to the wash cleaning region to clean, and then move to another stage. So this is one of example. So now this is our target is to make commercialize and then apply and transfer this machine to the local domestic small orchid foundry. The orchid farmer. Then I would like to share another case about the greenhouses robot for the fruit tree cultivation. So then, and this is as you can see from this video. So this is a traditional method. So the farmer used the hand and to spray the fertilizer or pesticide or the chemical to the papaya or the banana tree. So, but this one is not good for the health. So you can see the farmer wear a mask, and then the farmer want to prevent the contamination. So they use a quite very long stick, the spraying stick, almost 2 meter. But now Taiwan, this is quite common technology. We use drone to do the spraying. This is one case which is in the southern of Taiwan, and for the banana spraying. And then, but unfortunately, we know the drone can do a very fast spraying speed, right? And then can prevent the herbicides to the farmer, right? But unfortunately, so the spraying from the top to the down, so we can the water droplet can easily penetrate or the drop onto the backside of the leaves. Okay, even the ground. So now we have a quite commercialized approach by using the drone. So then my lab is focusing on another autonomous spraying vehicle. So this one can not only to do the spraying from the top side, and then this one we can adjust the direction of a nozzle to do the spraying from the backside of the leaf. So then my student designed several type of the autonomous spraying vehicle, ASV. So then, for example, this is composite of the one driving the vehicle, and with one small big water tanker with nozzles. And we make 3 different type of ASV. So, and this one is already commercialized. So my student already transfer and open a company to sell this, and it costs he sell the price is around 10,000 USD per car, but the government in Taiwan government can cover the 30% of the cost. And as you can see, we have several functions. This function is a simple one, so it's kind of like a play the remote car. So farmer can use remote control to do the spraying. So this one we already applied to the greenhouses for the papaya cultivation. So the farmer still using this technology, this remote control car. So another, we have added the camera and the magnet light to guide the movement of the ASV. So and also to do the simultaneous to running the spraying. So then this is another case. So my students sell this commercial car. So they this one can it's autonomous running. So we embedded the magnet line under the ground. So covered by this plastic bag. Yeah, and cover. And then so every day they just set the time, and then every day this car can automatically run the whole greenhouses. And then another is another type, and the tomato. So student put the camera, and which can detect the growth, the density of the leaf. For example, like in this case is high, so adjust and open the two nozzles to do spraying. So this one only lower, so the machine only open the one nozzle to run the spraying. This is worked inside of the cherry tomato greenhouses. And also students tested the performance of spraying because we want to make sure there is no huge difference or impact by using the robot, agricultural robot. So we want to make sure the robot can perform the same performance as a farmer using hand, manually operation. So then here is some data. I don't want to show this. So if later I will attach the paper's address. So if you are interested, you can just download the paper. So then another I would like to say another technology by using the UWB, the navigation system. So as you know, farmers always ask more and more. So first we give them the remote control function. So they say, okay, can you improve this machine? We want autonomous. So then, but unfortunately they want more. They want high tech, but they only they only want to pay less. So then that's why we use the magnet line. But another farmer mentioned, okay, so they want to pay more. They want to have a better performance, and then they hope this robot can run between each greenhouses, not only working inside one greenhouses, and after spraying, so the robot can pass the door and go to another greenhouse. So then also they request a low cost. So then we decided to use the UWB. So as you can see, we just need to put the 5 chip in at the corner of the greenhouses, and then the 5 and the one located in the central. And this chip it's not the high expensive, just cost $30 USD and with a small battery. So this is a demonstration. So as you can, and here we also do the precision testing. Sorry, so here you can see. So then this is a one take. We don't do any treatment in this video. So you can see, so yellow ball means a car, small car. So just one click, car can automatically run inside of the greenhouses and reach to this rate target position. So, okay. And Then after we apply, so farmer give us another super challenge, big challenge. They say, okay, your ASV can automatically run the whole inside of whole greenhouses, but how about when they running out the water, for example, like here, so then farmer must go back to the greenhouse and then control the ASV, go back to the station to refill the water. So they ask us to design, to improve and make a new function for this. So and then after refill the chemical, so the ASV can go back automatically, go back to the break point and then restart the job. So then, as you can see this, so this is a small demonstration inside my campus. So you can see here. So after refill, so this ASV can start. For example, we setting from start the spraying here and then make a U-turn. And then, so in this case, we put less water and inside has a sensor. So when the sensor detects the low level of water, so then automatically and go back to the refill station. And here we have a RFID tag and to refill. And after that, and then car can automatically go back to the breaking point and to restart. So this is another function which is requested by the farmer. So you see. And then this is one take. During the whole operation, we don't do any like you see. So when they reach to the break, the point, the position, the AGV record, remember, and keep the spraying and to finish whole job. Okay, so then definitely the most important thing is because my projects are mainly from the Ministry of Agriculture, so they don't request paper publication. They ask us to make a real workable machine. So this is how do they evaluate and then judge the pass or non-pass of our project? So normally they just go to the real greenhouses and check the function. So you see this is electricity spraying. So then we put also the same. We put the less water and then keep operated in here and finish the water and then go back to the position and then automatic and refill and then again. Okay, so here, right, and then again, now reopen again and to finish the old job and even automatically run the turn and then change to the next corridor. Okay, so this is another student put the camera to detect the density of leaf and then not just keep the whole spraying in the whole running, so and stop and then check the quality and then spray the one side and then move to the another side. So then we also compare the performance by using the hand and this robot. So we have a competence to say that, and then we can use we can reduce the 40% of water the chemical use. So then, and this is a real the sum of the results. So I don't show here. And then this is a publication. So my student and publish a good her result in the good journal. So yeah, few years ago and this year. So if you would like to see the details, so please check. And also we have used a robot arm to pick up, but unfortunately this is not the real useful approach because you know the normally robot arm costs the high price. High money, right? And but the working speed is very slow. And 1 hour we tested 1 minute maximum we only can pick pick up three strawberry or three cherry tomato. So it's not effective. So after the few, maybe the first generation is I want to make a fancy agricultural robot, but unfortunately it's not real usable in this. And then another is challenge is the tillage, the operation. So this is one case. So when the young farmer or the female farmer, if they drive this car to do the tillage, so normally they don't have a good experience. So they have to do the two things at the same time. First, they have to make sure the walking route or direction. And second is sometimes they have check the back side of the Taylor device. So here I show you this one video. This tractor was controlled by a lady. This is my secretary. So I give the challenge to my PhD student. I say, when the lady, she's a graduate from the business school. She doesn't got any experience at this. So you can see, so this is the first time she drive, and she doesn't got any experience. So not a very good driver. And then my student make two components. First one is we call the auto pilot in the steering wheel. So it just make instead of one motor to control the steering wheel. And then this one we instead like a GNSS, RTK, and also the UWB system. And then behind he developed another sensor to detect the dips of the rotary tailor, and then this one can be used to manage the dips of the land. Okay. So then in this case, some noisy. Okay. So then this guided model system was based on the GNSS and RTK and also the UWB. So here, this is our first version. So this is my secretary. So she control this tractor by watching the red line moving. So if, for example, like this one, the red line shift to the right side, so means car already shift to the designed line. So then she just have to check this red line and see the monitor and drive this steering wheel to the middle, make the red line located in the central of this. So you can see. So under this semi the function, savvy driving function. So she can, even she's a freshman, no experience, she can drive and really inside of this test field. Okay, this is another function. So first we have this function is more simple. So first driver only need to make 4 points. And then that means she just drive and make a circle and to cover the size where you want to do the path planning. So then after that, they can choose the different type of paths, like a leg or like maybe like a one line by one line. So after that, and then can just send the command to the auto steering wheel and control the driving of this. So as you can see, and this is another function. So then driver just drive a very short, kind of like around 3 meters, and make 1 point and 2 point, and then from 1 point to 2 point, so has a straight line. So this straight line will be the reference line, and then after that, the tractor can automatically run line by line. So as you can see, she didn't use hand to touch any steering wheel. So this is an autonomous running. This and finish this. And then definitely we tested. So as you can see, like this, this is the image showed how we set. So we find one A point and B point and make a one strike line. So after that, they choose the space. So then system can auto design how many lines and which can be followed by the tractor. And then you can see here. So you see first, and maybe only 3 meters to make a line to A point and to B point. And please check this, here. So then after that, automatically running, and to do this case we didn't do. So then here, safety is another important issue. So then I ask my student, I say, if something, because according to the Japanese law, right, they also have an autopilot system, but they request the farmer must sit on this tractor. So if any emergency case occur, so the farmer can control. So here we put one water pipe, then stop, and then when reach to this like a cave, so a farmer can also not only can drive the car by their hand, and then can control by the farmer. And then after that, and then just when he release the hand, so the driving is go back to the autonomous. So this is a app. So because one day farmer asks us, say they don't want to control the car or use the monitor, they want to use the iPad and the cell phone. So now this is we already put on the app already on market, so you can download and use. And this is one. Okay. And here is about some. I still have 6 minutes, right? So some tested and measurement data. So you can download the paper. Another is I want to. We also repeat the same system to the water lily. So maybe not every people know what's the water lily. Water lily is a very unique vegetable in Taiwan. So I think whole of the world only water lily, and Taiwanese people eat the water lily as a vegetable. So this is a general case. The farmer drive this tractor and via the UWB system, and then one side just put the seed and embed it. You see, as you can see here, into the water. This is a water lily, the cultivation condition of the water lily. So this vegetable is cultivated inside of the water. This is normally quite deep, 1.5 meters. So this is a unique vegetable already only in Kaohsiung, in my city, Meinong. So, okay. So maybe I only have 5 minutes. So maybe I would like to stop here. So, and keep the 5 minutes for the Q&A. Last one is exoskeleton. I quick show the video. Sorry. So here, this is a exoskeleton, which is as you can see here, has 2 motors, and then the sensor, we use the EMG signal to measure the activity of the muscle. So when you see the sensor detect the movement of this and drive the motor, and to assist when the farmers do or the bend it and then to hold it to carry some goods. So this one. So then we improve to the wireless function, the mode. So you can see this, but unfortunately, can show the commercial one. as I mentioned, the low-cost product in agricultural field is very important. So then finally, we issued transfer this technology to company. But this is only the driving force is only supplied by the spring and the gear. Okay. So okay, maybe I finish my presentation. So lastly, I would only like to say. So I still have some. So okay. Last page. So I only want to say, let's witness the future of smart agriculture together. Thank you. So maybe I have 3 minutes for the Q&A. Thank you.
Yeah, thank you very much for very impressive keynote speak from Person Lin. So have any question from audience? Yeah.
Good morning, Professor Wei-Chelin. Thank you for really interesting and like the really application research related to mobile robot. I have maybe short question, but 2 ideas. The first, in your localization system and navigation, I saw that you only use maybe only one sensor. For example, with one robot, you use ultra wideband, or another you use GNSS system, GPS, ATK. So in the case of we lost the signal, so how can system work? Because almost the navigation and localization system for outdoor, even indoor, usually they fusion several kind of sensor, but in here only one. The second is why you don't apply like the vision system? Because for the chemical spray system, with the human we can use eye to see that the spray is good for the leaf of the tree, but without the camera, without the vision. So how can we ensure that the spray is good for the leaf, or is it enough to stop spray, or we can adjust the speed of spray? That's 2 questions really relate to technical aspect in your presentation. Thank you.
Okay. So, for your question, so first before my background is mechanical. So then I also have the same idea and same aspect like you. So and we can use vision and we can use this. But because my lab is to develop a machine for the application in agricultural field. So after I work in this field, I find a totally different. It's a totally different world. And then the first important thing is we cannot keep using like a Tesla, the idea from that, like even use that, because few point. First point is cost. You know, normally. So from our side, so every time when we want to present the result to government, so we will prepare the 2 technology. One is very fancy, high technology, like I can tell you, we combine navigation system, we combine the UWB and then RTK and GNS, and even I have one student who is doing the image recognition, doing this, but this one only show off to the government and the conference and show like how strong of our muscle. But unfortunately, in the real field, farmer field, so they just want to use for and low cost, and then the working conditions are fully different. So like in the car case, right? And we always apply the autonomous inside of factory, but the ground, how is conditioned? The ground of factory is flat and clean, right? But outside is different. So sometimes this morning you got the big sun, right? And you have a hard shutdown trouble, challenge. And then afternoon you got the big running. But if the robot inside of a factory, you don't have this even in a clean room. So we open the air conditioner. So that's fully different. So maybe the same model and same idea cannot be transferred to the agricultural field. So then, so that's why you can see I always do one by one, but actually we combine together only just publish the good paper. So as you can see, my student published like the top 1 or top 3 of like one over like 80 something. So that's good and means we show the good technology. But in the real case, no. So like IXO, you have AI, you have everything. But the farmer will tell you, this is so stupid. So we don't put in the 2 motor. You know, every exoskeleton, you need the power. And then, so power, you have a mechanical way and electricity way. So you need a battery and everything. So they say, very heavy, very hard. And then battery is expensive, I need to recharge. So then we just make the mechanical driving tool. So then cheaper and useful, and they will buy. So also another big challenge is in this robot, so super expensive. Like you can realize, I think now we have a technology, and then even now we are working with NVIDIA, so we have a good result, but we cannot show. So you can do like a pickup, but the farmer will ask you 1 minute, and one night, how many strawberry you can pick up, right? So the speed and low cost, they want to check the value and the price. So this is my idea. We have some students who are doing this.
Yeah. Thank you very much for the answer very detailed. Because of time limitation, so we finish the first keynote speaker here, and please give Professor Lin a big hand, please. Yeah, thank you very much. Yeah, so we just have listened impressive and interesting about the robotics, and next one more very interesting keynote about the civil engineering. It's with the title, The Solid Waste Management Practice in Australia Case Study, from the Professor Chien Chua. Professor Chien Chua is a professor in the Sustainable Construction at the School of Civil Engineering Construction Management at Adelaide University. His main research interests are related to the health and sustainable built environment via both technical, smart technology, and municipal policy intervention and behavior change means. And he's had published more than 100 top journal papers, more than 80 journal paper indexed in SCI and ASCI, and the citation is more than 77. It's very impressive. So please welcome Professor Chien Chua for the late keynote. Yeah.
All right. Thank you, everyone. And in particular, I'd like to acknowledge the organizing committee and Vice President, Associate Professor Chandin. Hopefully, my pronunciation is past the test. And also the Executive Committee of the University of Technology and Engineering. It's my privilege to be invited to give keynote speak in this fantastic conference. I have to admit, this is my first time in Vietnam. I'm deeply impressed. I think there's a bright future for the city and for the university, considering the lot of infrastructure projects going on. As my fellow keynote speaker, Professor Lin, was talking about the aging profile of Vietnam is very young. That means we need a lot more buildings. We need a lot more infrastructure. And I believe this conference, talking about the green technology, talking about the sustainable development, that's the future. I think that's an excellent platform for us to exchange our idea and also developing the collaboration. So my presentation today is basically a summary of my research group in last probably few years, looking at the solid waste management and recycling. I think that fits very well in this conference because we're talking about sustainable development, and solid waste is one of the key issues. And for many of you, I guess, your image of Australia would be something green, that we have a lot of grass, green space, and the blue sky and blue ocean. So everyone will perceive, okay, Australia don't have any problem in terms of environmental pollution. And I have to tell you, we do. We do have a lot of challenges in terms of environmental pollution. And solid waste is one of those. You can see all the photo images over there, and on the top, sorry, that's okay. So it's one of the beaches in Australia. It's full of rubbish has been washed to the beach, and you probably recognize the bottom left corner, and I'm sure you recognize this is solar panels. And many of you say, what's wrong with solar panels? Solar panels has been classified as one of the most clean energies. And I've seen, even on this campus and a lot of other buildings in this city, there are a lot of solar panels being installed. But have we ever considered what's going to happen to these panels in 20 years' time? Well, if you do, congratulations. You've picked up something very important. And my group is lucky that we've been working with the industry and the government looking at the potential pathways to deal with this waste. Because it's too early to report those studies, so for today, I'm not going to talk too much about solar panels, sorry. But I think this does present some opportunities for the future collaboration. And considering Vietnam is also very much encouraging the clean energy, so solar panel would be a lot we're going to see in the roofs. So, I think I've got 30 minutes to talk a bit about of the everything, including the background, but also some of the case studies. I'd like to introduce some of the background about what's happening in Australia, because that will give you some idea about what's happening over there. As I mentioned, many of you may consider Australia is quite clean. Yes, we are lucky, have a lot of land, and we don't have a lot of population. So we're lucky, but if we look at the statistics, we do generate a fair bit of waste, solid waste. And what is worrying sign, from my perspective, is in last probably decade, the government has introduced a lot of policies and has provided a lot of funding to improve that circular economy, which is very topical. However, what we have seen is the waste generation per capita is actually increased. To me, I think that's a very worrying sign, because it's not because we are not aware of it. It's not because of the government don't believe it's important. What worries me is, even with those efforts, we are still generating a lot of waste, and the waste per capita actually increases. And I'd like to share with you, these many cases could be related not just the technology, as was Professor Lin has talked about, these brilliant technologies in place, but also some of the environmental awareness, behavior. So my university, like other university, we have a policy called Compost Campus. So we have food courts, like, where students, staff members enjoy food in food courts. And we do have the containers for the food, like the food containers. And you probably have seen a lot of food containers are made by plastic. Now my university has introduced composter campus policy, which means all the food containers has to be compostable. So just imagine, after you have finished the very delicious meal, you don't have to worry about whether it's going to end up with the wrong hands. It's going to be sent to the composter, which will be made by for the composters and for the gardens use, etc. But I'd like to share with you that after we have done some auditing of the waste on campus, very interestingly, what the connectors coming to pick up the composter bin, which is green color, green bin, refuse to take it. Do you know why? What happened is all the rubbish bin come out with a liner, so that plastic bag, a kind of compostable bag. So the green bin, because it's sent to the composter, so the liner, within the bin need to be compostable as well, so which is the green color liner. So when the connector come, they only have to take the bag and just chuck it in the truck, and they can send to the composter facility. However, what happened is the connector found the liner is not green. It's not green bag. It is black bag. What does that mean? It is not compostable. So the connector come to say, we don't want this because I don't want my staff to take anything out of that black bag and send to the composter. And then we found that, okay, can we just talk to the cleaner? So the cleaner come forward and say, she was very upset because she said, I thought I'm giving the university a favor because the green bag cost 40 cents. And the black one, which is not compostable, only costs 10 cents. So from the cleaner's point of view, she believes she actually saved the university 30 cents for every bag she used. But the reality is, that cost the university probably $100 because that has to be sent to the landfill. So I think that kind of, a lot of, non-technological factors could pave the way. And I think this will be covered a bit in my presentation today. So I will skip some of the fundamentals. I'm pretty sure you are already familiar with those. So in Australia, we have different statistics. We're talking about recovery rate, we're talking about recycling rate. The only difference between recovery rate and the recycling rate is the recovery rate also includes waste to energy, so waste incineration plants. What happened is in Australia, so Australia is not a big fan of waste incineration. You probably ask me why. What's wrong with the waste to energy? In Australia, there are certain number of people believes that waste to energy is a waste because other than recovering the heat or turning the heat into the electricity, the waste is gone. So this is a school of thoughts. They would like to see this to be back to what it meant to be. For example, the glass. They want to see the glass to be made back to the glass. For some people, to turn the glass into the sand is the waste. It's not circular economy. I'm not here to advocate one or the other, but I think, I firmly believe taking a broader approach for the circular economy will be better. So as you can see this, the recovery rate in Australia is quite different from state to state. So if you look at the jurisdictions, the state I come from, South Australia, is doing so quite well across all the jurisdictions. And look at the different sectors. The building sector is absolutely taking a major role. And I'm sure my colleague Brian is going to talk about his idea of using new technologies like digital twin to make something out of nothing. I'm looking forward to Brian's presentation as well. So this is the flow of the material flow of the waste. As you can see, a lot of the construction and demolition waste still go to landfill. Even with something like 60% of the recycling rate, most of this waste went to low-value applications, such as the backfill or the road base. So there's a strong push by the government trying to improve the high-value recovery of the materials. And I firmly believe there are a lot of potential, like Australia, to work with Vietnam and with university and industry on this. If you look at the waste hierarchy framework, surely the last effort is to disposal, but there are a lot of other things we can do right from the beginning to avoid the waste generation, to reduce the waste generation through the good design as well. So, as I mentioned, the government has taken a lot of efforts, including introducing the policies, having the ministerial level of advisory group, and also provide the funding. The product stewardship is interesting. I like to mention the product stewardship here because for the solar panels, Australia is now introducing the product stewardship program. So if, say, for example, if Australia import solar panels from Vietnam, the manufacturers actually is going to take certain responsibility of the end life treatment of the solar panels. So the product stewardship is a good way of dealing with those problematic waste streams, including solar panels, including batteries, is well accepted as something really useful to deal with those waste. I'd like to introduce the case study background. I'm using South Australia as an example. So you can see this ecosystem of the waste management or circular economy. So in my state, we have a lot of city councils, like local governments. They have their own legislative power. They can introduce their own way of dealing with waste and circular economy by dealing with the waste connection of the households, the curbside connection. And then at the state level, we have EPA, the Environmental Protection Authority, who would make the rule in terms of, what's the licensing. So who can deal with certain waste, such as solar panels. And then we have Green Industry SA, which is a quasi-in-government department, who provide a lot of funding to support the development of the renewable circular economy market. And I like to use the soft plastics as an example to show the case studies. The reason is soft plastics is classified as the most problematic type of plastics. My team has done a fair bit of research on other type of plastics such as PVA and PET. That's easy to deal with because there's a certain market for that. For the soft plastics, it is hard because nobody wants it in Australia. So, however, there are different ways of doing that, but basically we are talking about who is generating it and who is going to connect it and who is going to be responsible for putting it back in the ecosystem. So, for example, this is an interesting case study, and as you can see, there are certain applications like the viewing platform in the mountains or beautiful beaches, the fence and the fender and decking. These can be made by composite materials, by incorporating the soft plastics. So there are a few factories, businesses are putting these soft plastics together with the pine wood from the reclaimed sawmills. And by using the recycled aggregates, and then with the high pressure and high temperature, we become wood plastic composite material to be used in those kind of applications. So that's quite useful, and of course we have also seen some of the use of the recycled soft plastics in the ash fields. So I think our civil engineering colleagues will be very interested to see that, because we can actually take some certain soft plastics which is so problematic by avoid sending them to the landfill. As I mentioned, the local councils play a certain role. It's not just the state government or the Commonwealth government. The local councils could come together to form a workforce on that. So this is one of the initiatives called Buy It Back. So there are 9 councils. They work together to take their waste and remanufacture, recycle and remanufacture, and repurchase. So they have what we call circular procurement guidelines to take, for example, the glasses or plastics and then send to the recycling businesses and then remanufacture into their products, for example, in the pavement, etc. And these are the other applications. Again, this is more about the building materials. You probably have seen some of the component on the left-hand side. This is called wheel stopper. What happened is in the car park, when you try to stop the car, they normally would have something on the front. When your front wheel start touching the structure, that means you need to stop. Because if you speed again, it could hit the wall. So traditionally, the material being used in this structure is by the concrete. Easy. We can make it in the factory, precast it. But as everyone knows, the concrete is very heavy resource and also carbon intensive. So again, this material use the plastics and wood powder to make it, which largely reduce the emissions. On the right-hand side is a system called bubble deck slab. So this is the typical floor system being used in Australia. So imagine for the typical floor system, which is normally in situ concrete. So you see the construction workers to pull the concrete floor with the reinforcement in between. Again, if it is a traditional way of the concrete, in situ concrete, it's going to be very, very carbon intensive because of the concrete itself is very emission intensive. This technology is, so you can see this, is a hollow plastic ball. Okay, this is made by recycled plastics, which mean to be sent to the landfill if we do not use that in this kind of system. The benefits is quite obvious because we are using these hollow plastic balls to replace a quite large percentage of concrete. And so you can imagine there are a lot of benefit of using this technology. By replacing the concrete, we reduce the carbon emissions associated with the concrete production. Also, this kind of structure is going to be lightweight. And imagine if we have to lift, if it's a pure concrete floor, which could be heavily rely on your lifting capacity of your crane. Because it's lightweight, so which means you don't have to use the very high lifting capacity of your crane, which is handy. You will save the money and you save the energy as well. I just noticed I've only got 10 minutes. I will skip some of those. So apart from those new materials, I'd also like to introduce you some of the policies, the studies we have done. And as you're probably aware, like Australia, there are certain waste trade. So if you go to the UN website, you will see a lot of data talking about like, Australia sending the waste to Vietnam, for example, for treatment. The reason is very simple. Like, for example, Australia may not have the capacity to treat certain waste, or the destination country has better way of treating that certain waste. So what we did is we look at the data set from the Australian government. So we look at where we exporting the waste. Why we did this research? We are inspired by an argument saying, when we send the materials to overseas, we are assuming the waste will be treated properly. So in other words, if Australia cannot treat it, maybe we can find our partner country, a nation, to be able to treat it properly. So this is what we found. For the plastic, Australia mainly sent to Malaysia, China, Turkey, Indonesia, and Spain, whereas Indonesia and China has reduced the waste being receiving. What we found in this research is interesting that there's something we cannot take as granted. The reason I'm saying this is when we assume the waste will be recycled in the destination country, and if you look at the data, it's not always the case. So when we are exporting the waste, we thought we are going to reduce the emissions, reduce the environment note by doing this waste trade. It's not always the case. So we are advocating to the government, say we probably need to rethink where we're going to send to by looking at the overall mutual benefits between Australia and the receiving country. We also look at the policies. As you can imagine, the policies to manage the waste is quite different. And even in Australia, because we have so many different jurisdictions, and their policies are quite different. So what we did is we look at different policies from different jurisdictions. We really want to understand, will this policy be effective or not? So we have 4 options. Like the first one is to introduce landfill ban. The second one is internal hazard waste tracking. The third one is a combination of these 2 policies. And the last one, of course, is no policy. As you can tell, introducing both policies help a lot in terms of improving the effectiveness of the waste management. Of course, no policy is the worst option. But it's quite interesting that we found that internal hazard waste tracking is better than landfill bans. I also like to introduce a little bit about the illegal dumping research, as we want to understand what can we do for illegal dumping. So if we have done quite a lot of technological innovation, if we have introduced a lot of policies, why there are still something ended in somewhere which should mean to be. So we look at the way we manage the waste in terms of the illegal dumping. Traditionally, we normally just send people to remote areas for patrolling, but it's very, very effective. And using GIS is very limited capacity. So we try to design a method we can identify or detect illegal dumping, but also save money. So we try to use the geo-information analysis and a machine learning method to map the high-risk areas. So what happened is we select an area. We have a lot of data from the data assay. So we got the geographic data, traffic data, and the natural data. So we look at the factors such as the trees, social in terms of the store distance and also traffic. So what we did is we found, rather than just ad hoc thoughts of the interesting area points, we got a high risk section of the roads like this. So the accuracy can be much improved. So which means if we do have to send the patrol, we can send the patrol to those red lines, which means that section of the streets are highly vulnerable to illegal dumping. So we can see this, subject to the traffic lights distance or store distance or trees. All this could potentially link to the vulnerability of the illegal dumping. We have to acknowledge that the data could change along the time because the tree could be small now, and for a few years' time, they could be large. So we also did a forecasting, and according to our forecasting, the hotspot of the illegal dumping is moving towards northwestern of the area. So that's my presentation today. And I firmly believe by working together, cross-discipline, across the country, we are in a good position to tackle this problem. I think as academics, we always feel that this with the problem, this is not a big problem, as long as we can find a solution. So let's work together to create something not just for us, but also for our future generations to come. Thank you.
Thank you, Professor Jian Yu, for the interesting presentation about the current trend in construction sector, how to manage waste, solid waste. And I would like to invite participants to give the question to Professor Jian. Professor Tip, do you have any question?
Okay, thank you. Thank you very much for the presentation. And yes, honestly, Australia are very advanced in recycle. So particularly for Adelaide University. So can you tell me about a little bit about the future direction for the recycle, particularly when you see about Australia compared to China and also Vietnam? Yes.
Thank you. Thank you. Thank you, Professor Tip. That's a good question. I think every country has their own set agenda, and for example, in Australia at the moment, if you can tell the government you can fix the solar panel issues, you get a lot of investment and good policy. So we're talking about that, a lot of panels being retired and have very limited spaces that can be sent to for the recycling. And we have been asked by even the solar panel installers to deal with those panels that potentially can still be usable. So I think Vietnam also has a very set agenda, and Dr. Tu was talking about the smart technologies. I think, I'm just thinking aloud that if we can think a bit further ahead, like what we did probably 10, 15 years ago when we start promoting clean energy such as the solar panels and wind turbines, we probably very few of us have thought about what's going to happen to these panels or wind turbines when they reach the service life. And if you look now, back to 20 years ago, we said, did we make a right decision at that time for promoting the clean energies? I think yes, we do need these clean energies to deal with the energy poverty and also reduce the emission associated with the traditional fossil fuel. No doubt about it. But I think it's time now that we need to think about our future generation, because maybe we don't have to worry about it for this generation. They're probably not going to create a lot of harms. But for our future generations, it's going to be a challenge. And if we can start planning what to do with those, and particularly if we can work together from different disciplines, like what we're doing is we're working closely with chemical engineers. They only worry about the metals, but we can do a bit more about using these panels in civil structure and also the environmental monitoring. And suddenly we said, why not we work together? And probably we will see some of the trades that have to happen across different countries so that we can work together on these emerging challenges, which I think every country is probably going to deal with in the future. But thank you very much for your question. Very good question. Thank you.
Thank you.
Okay, thank you, Professor Jian Zhu, and thank for your advice and suggestion for our country in the near future. Okay, thank you very much. And I think we should give him a big hand. Thank you very much, Professor. And now, the last but not least, I would like to introduce a special guest from the industry, Mr. Brian B1 Kaur, CEO of Integra DNA Korea Innovative Design. He will present the topic related to from the sustainable architect to climate content entrepreneur. We welcome you. Thank you very much.
Hello, everyone. Good morning. My name is Brian Ko, and I'm presenting today mostly like my personal story about how I became the sustainable architect to a climate tech entrepreneur in South Korea. Mostly because I'm an architect, I show you just great pictures of the buildings. So no texts and no academic research papers. It's very easy images that you can see. First of all, I'd like to introduce myself. I am an expert in zero energy building design and also green remodeling. I've been practicing architecture for 27 years in the United States. So I'm currently the CEO of Innovative Design, which is a sustainable architecture firm in North Carolina of the United States. But at the same time, I created Integra DNC, which is a climate tech startup in South Korea in 2018. I've been serving the U.S. Green Building Council community while I was in the U.S. So I was the chairman of the U.S. Green Building Council North Carolina chapter, as well as also lead faculty, which was teaching the lead workshops around the country in the U.S. as well as overseas. As I said, Integra is a Korean company that I created in 2018, so it's been 7-8 years now. And Innovative Design is an architectural design firm in North Carolina, which was founded in 1977, so I didn't found it. I joined the company as an employee, and then I became the owner and then CEO now. So what I do with these two companies together is Innovative Design has focused on sustainable design, green schools, and other things in zero energy buildings and green buildings for many years. And Integra, on the other hand, is a relatively a new company and focusing on the sustainability and climate change issues in the built environment, especially in the buildings. So my interest of being a sustainable design architect became this entrepreneur of climate tech. Probably I'm going to show you two pictures. One, this magazine cover was Metropolitan Magazine in the US in 2003. So almost, 23 years ago? And the title of this magazine was Architects Pollute. Just two words. Architects Pollute. And it shocked me. Because until then, although I was learning LEED and I was learning green design, I thought my work was really improving the community, improving the society, and then I thought I was doing really great design practice to improve energy efficiency and other things. But then this magazine totally changed my mind. Architects pollute. And I thought about it. Yes, everything we do, civil engineers here, a lot of civil engineers, architects, we do something for the humankind, and then still we pollute, no matter if the building is zero energy building. And Professor Joe actually talked about solar panels, right? Solar panels were developed to generate electricity from the sun, which should be great, but now it's generating wastes that we have problem. So this magazine impacted my life a lot. And the second thing, second factor is this person. I don't know if you know him. Anyone who knows this gentleman? He's an architect in the United States. His name is Ed Mazria. If you are in the architecture and especially the sustainable design, you have to know Architecture 2030 Challenge. He created this challenge, the civic movement among the architects many years ago, about 2001. And he was promoting that all the buildings that architects design should reach net zero by 2030. Back then, when he started this movement in 2001, the 2030 felt like it's a long way to go. But now we are in 2026, so 2030 is almost like 4 years to go. And he started this movement, and he charged all the U.S. architects to design their buildings much better than they used to do. And he impacted my life also very much. Okay, so I'm going to show you several projects that I designed that I can tell probably one of the best projects that I've done. First project is a college building in Clyde, North Carolina, in the United States. It's an aerial photo from the sky, looking down the building, and you can see a lot of solar panels on the roof. Okay, and this building was designed in 2008 and 2009, so it was like about 5 years after that magazine and Ed Mazria's 2030 Challenge. This building was designed to be LEED Platinum. I don't know if you know the LEED certification. LEED Platinum is the highest level of green buildings in the United States. I'm gonna show you one by one. It has a lot of green technologies in it. As I said, this was designed in 2008, so almost 20 years ago. But if you look into this building, still a lot of technologies are way advanced than the current practice that we do. Because of the time limit, I'm not gonna explain all the details of the technologies, but you can tell solar thermal, solar PV system, natural ventilation, underground rainwater system, constructed wetlands, and even the xeriscape plants and many other things, cool roofs and many other things in the project. This photo shows you solar thermal panel that was manufactured in Germany back then, and it creates almost 98 degrees of hot liquid, not just water, hot chemical liquid, and we store in the tank over there, and we use that water for cooling and heating of the building. Not many buildings still use this technology these days, but I worked with my mechanical engineer to implement this 20 years ago. There's constructed wetlands, which is also kind of man-made, a pond, but it purifies the water, the stormwater runoff from the parking lot. So even if we built this new building in the forest, on the campus where the trees were, the stormwater management after development is much, much better than the previous one because of this pond that we created. So it treats almost 90% of the site and an immediate site of the stormwater runoff. Probably this one slide is the most important informative slide for you if you are building engineer or architect. It has a stack ventilation system, so it promotes like a natural stack effect throughout the building. If you studied architecture, you might know the passive design, and one of the passive design strategies is this stack ventilation. So I use that, and then also the natural cross ventilation strategy, solar thermal cooling and heating, and also even radiant flooring. So we are doing a heating system through the radiation on the floor, which is very common in South Korea. And then energy efficient building envelope, very, very high efficient, closed cell polyurethane insulation foam, which is number 5. Number 6 is photovoltaics, the solar panels. And then even the solar thermal hot water, and then exterior light shelf, which is also another passive technology that we implemented. So this is the inside of the building using the daylighting, mostly about 2/3 of the daytime. We don't need electrical lighting because of the daylighting design that I did. And other studios and workshops are all day lit very well, but it does not really receive direct solar heat gain. It's all distributed daylighting for better work. So to summarize, all the solar technologies, it's not just one technology, it's various technologies that I implemented to become LEED Platinum and Net Zero building. And it was featured on the national magazine called Solar Today. And the second project that I'm showing you is Isaac Dixon Elementary School, also in North Carolina. Because this was an elementary school in the mountain area, we had to honor the nature. And also the school curriculum was very specifically designed to work outside more so the kids actually can connect themselves to the nature. We have, because this is an elementary school, young kids, we have educational signs all around the campus to educate them using my building about sustainability, about renewable energy, about stormwater system and things like that. And I designed, this is a cool thing that I designed it. It's a solar clock actually on the wall. And I designed it, this sundial, and then explaining, how the sun moves, so kids can actually learn and experience, not just on the textbook, but in real life, how the sun moves throughout the year. This is a stormwater wetland that I created also that treats the stormwater runoff from the site and then clean it and then release it back to the nature. Inside of the buildings, classrooms, even the classrooms, if you look at the window types, actually even I select window types based on the evidence. So I run energy modeling and daylighting simulation to make sure that they have quality daylighting. It's not sunlight, direct sunlight, because when you receive direct sunlight, when you study, then mostly people, what they do, they shut the blinds down, okay? But in order to avoid that, I chose a translucent, not transparent, translucent glazing at the top of the windows to filter the lighting. And in the lobby, you can see this fossil, the dinosaur fossil. It's called the mosasaur. It's a aquatic dinosaur that we got the donation from archaeologists. This is a library photo. All the lights were off. I turned all the lights and then and then the lights were on, but you can see the daylighting coming from the ceiling over there is really kind of comfortable for the reading area. And the third project is a more recent project. It's another middle school in Saipan, which is a Pacific island near Guam. This is a U.S. territory, and this has not been built yet. I finished the design, and it's going to start the construction just in about a month. Because of the area being in the Pacific, their sustainability concern is durability and resistance to the storm, the typhoon, like you have here. So I chose a lot of materials based off of that requirements. It's got to be durable. It's got to be easy to maintain, and also it can resist against flying objects from the typhoon. So it's kind of main parking lot and then a main entry. And this is a classroom wing. So mostly it's either concrete panel or metal panels. This is the back side of the building where kids can gather and do outdoor classrooms. This is inside the classroom. Again, when I design a classroom, it's very specific to choose the size of the window, so it's not oversized, it's not undersized, and then also the screen wall is shadowed by the lower ceiling, so it can have a better visibility to the screen. So everything has a function, and then I intentionally designed to make the indoor space much better for the learning environment. This is a library and the reading area. And this is the main hallway, main entrance from the parking lot. These days, the schools, they actually promote some kind of these smaller spaces for the students to gather and then kind of have interactions and conversations. So this is like open learning area inside of a corridor, and another open learning area. Okay, so far these were kind of 3 projects. I've done many projects, but the 3 projects that highlight kind of my focus on sustainability. From these buildings, when I designed these buildings, I always had to think about, okay, what if there were this kind of product? What if there were this kind of technology that could improve the energy efficiency of the building? So I thought about new ideas and hopefully new technologies that would come out. So that motivated myself to become this entrepreneur of this new startup focusing on climate change issue in the building environment. And we have 3 different technologies that we've developed for the last 7 years. So I'm going to introduce one of them each. IUES is a exterior modular facade system that you can actually see and feel in the lobby. We have a booth for IUES system. So during the lunch or break, please feel free to come by our booth and then take a look at the technology. So IUES is a exterior wall system, very fast and very economical and safe. So the building industry has many problems. Like, we have a lot of existing buildings that we have to renovate, and also cost is rising up, and the schedule is always tight. And then accidents are actually a huge issue for human rights as well. And the noise and dust from the construction sites are always like an issue in the communities. And labor, like he did in the agricultural, same thing in the construction. The labor is being short. And then, also when you build an exterior wall of the building, usually if something happens like water leakage, then people just point the fingers at each other, trying to find whose fault it is, right? So in order to solve all these problems, I created this product called IUES. So what is IUES? Can you turn on the sound of the video?
Dividing it into units. Basic exterior wall components like insulation, windows, waterproofing, and finishes, plus HVAC and solar power, are all unit integrated during production. Each unit is assembled in the factory, and then the frame is produced so that it can be easily and quickly installed on site. For the exterior finishes, you can choose Building Integrated Photovoltaics, BIPV, or common architectural panels such as stone and metal. Window sizes are also adjustable through consultation during the architectural design phase. Combining various colors and materials enhances aesthetics. IUS actively adopts the off-site construction method. Each unit is manufactured in the factory while other construction work is underway. We can manage quality effectively because we reduce on-site labor and allow specialized personnel to produce in a stable environment. Once the units manufactured in the factory are safely transported to the site, approximately 180 square meters of exterior wall can be completed daily. This is achieved with only about 5 to 6 on-site workers using a crane and a forklift. Once IUS has been installed, the indoor solar power electrical connection and interior finishing panel work will then proceed. The IUEs is an exterior material that is completed quickly and easily. So, what?
Okay, because of time limit, I kind of cut this video in the middle. So again, it's off-site manufacturing and on-site installation, very fast. And also on top of that, we developed software as well. So RISCA is a real-time indoor space algorithm that we can adjust the temperature based on people's preference. So MEDI is my environmental type indicator that we can survey the people in the same room who prefers which temperatures and humidity, and then we can find the optimal range of adjustment in temperature and humidity. The first project was done in 2023, and look at this product. Look at this project. That amount of the exterior wall, including solar and the heating and cooling system, was completed in 3 days. So very fast, very safe, and then very economical. The technology, so again, that amount of the wall can be installed in 3 and 4 days and can save energy by 32%, and then heating, cooling expense by 30% reduction. The second platform that we developed is called ICAP, Integrated Carbon Assessment Platform for the construction industry. You can visit icapforbuildings.com, which is in service. Why greenhouse gas in buildings? Because it's expanding. The greenhouse gas protocol and requirement is expanding from really a high polluting industry to construction industry in the world. So I have prepared for that timing coming up. And also, it's a business opportunity for me to collect the data and then use that data for future use. And if you go to these big companies around the world, like Jacobs or Skanska, even these big construction companies now focus on reducing greenhouse gas emissions. So our ICAP can track not only scope 1 and 2, I don't have time to explain scope 1 and 2, 3, what they are, but if you are into the carbon footprint research, then you might know this. But ICAP can track every day of construction activities from the daily papers that we can track not only scope 1 and 2 carbon emissions, but also carbon scope 3 as well. So it's very accessible. The field managers and superintendents, they can use this software very easily, and even they don't have to actually, they actually upload their Excel files and PDFs that they already have, and then our software can calculate that automatically and then create the report. The third one is IDOM, which is an acronym of Integrated Digital Twin Operations and Maintenance. We started actually this development just about a few months ago. So it's not in service yet. We are in the development. So I'm just showing you what we are trying to achieve. Okay. IDOM is integrated with AI agents. With these days, you cannot even do any work without AI being involved. So we create two AI agents that I can tell you, but we try to detect the occupancy rates and status from the building by using non-intrusive sensing, and then we can predict. So we can predict if this space is going to be used in the next hour. If so, then how much of cooling or pre-cooling we have to do actually in advance to save energy and things like that. So we have this predictive control, and then also we are not setting the temperature at just one number. Like, if you set 25 degree or 26 degree, it's not like that. We give the range of the comfort, and then depending on the people and their preference, we kind of adjust it by using AI agent. So IDOM, we collect the data, many data. So because when you use AI, data is very important. So indoor environmental quality data, energy data, and then even the user feedback data, as well as PMV and BIM data, all of them into our database. And then we use those data to do fault detection and diagnosis, FDD. And also we try to make the decisions based off of those data, and then predicting energy and environment, indoor environments, as well as we control systems in a multimodal status. I'm sorry about some of the Koreans, but our various levels of services go to AI facility as service, a subscription model, as well as ESCO project, energy saving construction project, and then also we can use our ICAP and IDOM as a kind of combined service as carbon asset management. And our real target is doing this whole facility operations maintenance based on the database, AI, and other technologies. And one thing that I did not include in this slide is this IDOM technology is being developed not only by Integra, but also with Hanyang University, as well as Nasentech in Hanoi, Vietnamese research lab by the government. And also we are implementing IUES and IDOM at the Ho Chi Minh University of Technology. So I am working with almost 10 Vietnamese researchers and PhD students to develop this product. So again, I'm looking at this Vietnam market as a very high potential market to implement these technologies, and I'm working with some of you. Okay. So again, to wrap up my presentation. The title, I know this was a very short time, and I wanted to kind of inspire you. I was just a regular architectural student who was interested in green building design back in the 90s. And then I became the architect focusing on zero energy buildings, studied a lot, had a lot of ideas, and then I wanted to become the entrepreneur who actually make those ideas happen in the real world. So wherever you are, if you are a PhD student, master student, you might not be able to look out your future very long, but wherever you are, keep thinking about what's going to be next, and don't be afraid of doing the failure. This is what I really like, from Winston Churchill. Success is not final. And even the failure is not fatal. And it is the courage to continue that counts. So if you continue your efforts, although if you fail, it's going to be successful. And I think you're going to be at some position probably on this stage 10 years, 20 years later. And I hope this inspires all of you, especially the young students. Thank you very much.
Yeah, thank you very much for the very, very interesting presentation from Mr. Brian. So I would like to invite some questions from the audience. Yeah.
Thank you, Mr. Brian, for a very innovative talk. I have very two short questions. The first is, what is the biggest challenge in commercializing your climate technology? And the second question is, how do you measure the real world impact of your solution on the carbon reduction?
Yes.
Thank you.
Good question. Very good question. As I said, always there are challenges and barriers, especially when you introduce new technology into an existing industry. Especially the construction industry is one of those industries that are known as the slowest and most conservative industry. I mean, if you look at the construction sites 30 years ago, the way that they use reinforced bars and concrete and the way we use now, almost same, right? People know that construction industry is the most conservative because if you fail during the construction, then basically the building becomes your safety issue, right? So a lot of construction companies do not want to take new technologies. That's probably the biggest challenge. The second challenge is actually people's mind, I would say. So when I have a long list of ideas on my phone that I've been collecting for 20, 30 years. And I've done only like very few of them, okay? But when I present my ideas to other people and I get negative thoughts, I get, oh, I don't think that's going to work. And so I think changing people's mind, especially people that I can work with in my company and when I hire people, to get them on the same page, that is the most challenging thing. If I can persuade them, if I can show them this is going to work out, then I think everybody's going to say, okay, this is a great idea. And of course, in the construction industry, construction cost is always another barrier that you have to. People do not want to spend more than what they used to pay. So even if this new technology is great, until they see the economical benefit, they're not going to. So at the lab level or as a researcher, you might be able to create really great technologies, but in order to commercialize them, cost has been always the barrier. And the climate impact, and to be short, I think, if I can expand my services to many existing buildings, especially I focus on existing buildings and renovations because we can build great new buildings, and there are a lot of good architects who can design new buildings. But considering all the existing building stocks, unless we want to demolish everything and then create a lot of wastes, we have to reuse them. But there are not many technologies that can promote this reuse of existing buildings. So my IUES system actually can be hung on the existing structure once you demolish the exterior wall system. So at least we can preserve the structure. So I focus on remodeling, and that's going to actually create more impact on the built environment. Thank you.
Yeah, thank you very much. So, have any question?
I'm going to be sticking around if you want to just catch up. Yes.
So, if not, so I think because time is limited, so Once again, good night to thank you, Professor Mr. Brian. We give him a big hand and yeah. So now I return the stage to the MC.
Thank you so much, Dr. Châu Đình Thành, together with Dr. Vũ Văn Phong for the moderation of the plenary section. Ladies and gentlemen, that concludes our plenary section for GTSD 2026. Thank you again to the keynote speakers for their sharing of knowledge with us today. So I have some announcement for you. So as scheduled, the breakout section will start this afternoon at 1 p.m. So please kindly refer to the conference booklet so that you can know what the breakout sections are and where they are. And after that, in the afternoon, after breakout sections, we will arrange the bus to take you to the Seasand restaurant for the gala dinner. So after the breakout sections, may I invite all of you to come back to this conference hall at around 5:20 so that we can arrange the bus for you, or else you can follow the instructions of our staff. They will take you to the bus and then you can move to the Seasand restaurant for the gala dinner. But right now, are you hungry? Yeah, I'm sure you are hungry. Although we have some refreshment over there. So luncheon will be ready in about 15 minutes. So you will see the portable ones over there will be removed and you will see the food awaiting us on the sides of the conference hall. But we need around 15 minutes to clear all those conference chairs and we will replace them with the table and chairs for you to sit and have a buffet luncheon. So thank you so much again for your presence in this plenary section. We will see you back in 15 minutes right here for the luncheon. Thank you and see you later.